Okay, this is our first lesson on quadratics in grade 11. Really, we have talked about quadratics a lot already. In the first unit, we did transformations. We talked about vertex form, transforming a quadratic from the general form to what we have in vertex form, like shifting the vertex. We've talked about a lot of things already. We have talked about factoring in the last unit. So we have done some of these expanding binomials. So we've done a lot of the groundwork that we need to. But now in this unit, we just really explore the quadratic function and everything there is. So what we're going to talk about today is just representing and interpreting quadratics in a number of different algebraic graphical forms. Really, it's the algebraic forms. So these are your three forms that we've talked about in grade 10, and they come back here again. And we just really need to be very good at recognizing what each form tells us and how to convert from one form to another. That's where the algebra comes in. But really, that's the big thing about quadratics. We're going to get into a lot of skills, and so we're going to list a whole bunch of things right now. But the big thing about quadratics is that you understand those algebraic forms and how they relate to the graph. Because if you can understand that, you can understand things like, well, if a ball is launched in the air, what am I trying to find out? If a company has a profit model, what is each point telling me? We can talk about solving other problems wherever we multiply things together, things like area, length times width. But if you understand what it looks like, then it really helps you, and how to convert from one form to another. It really will help you just summarize quadratics so that you're really just looking at these three forms. So everything you can remember about quadratics, if you want to pause the video and just try to list down everything that you can remember, it's a really good exercise. So we're just going to walk through some of them right now. So we've got things like the vertex. So we talked about what the vertex is, what a step pattern is, really how to graph a quadratic. Does it take that 135 or a multiple of 135 a step from the vertex? Zeros or x-intercepts, what do those mean? There's two of them. Do both of them matter? Quadratic formula. So we're gonna talk about the quadratic formula again, and when we have to use the quadratic formula and what the quadratic formula gives you. The y-intercept. Why is the y-intercept important? How do you get it? The axis of symmetry. How does that help us really graph a quadratic? How does that help us say what's going on? The parabola shape, so this nice symmetrical shape. The three forms, that's going to be the big idea here, is the vertex, factored, and standard forms. Factoring, so there's what does factoring do? When can you factor? Why do you factor? Completing the square, which is really like a type of factoring. When do you do that? Why do you have to do that? And then max and min, so like the point, but really like the maximum value, and that relates to the vertex. And second differences, and just want you to practice second differences on page 145, number 1. It's not really something that we do a lot, but it's just something I want to remind you of that exists, and it's just subtracting the y values twice. So you do it once to the y values and then do it again to the first differences. And if those are the same, then you have a quadratic. If they're not, then it could potentially be something else. And when we get into exponentials, we determine what to do at that point. So parts of a parabola. So we label each of these parts. So the first part here, you can kind of guess what that is. That's the y-intercept. And I say when x equals 0. That's really important to kind of state, because we often don't think of that as a point. It's just like the value that's obvious that it goes through, but it's when x equals 0, because that helps us find the y-intercept. These 2 points are your x-intercepts. We also call them zeros. We can also call them roots. And we generally call them roots when we're not looking at a quadratic, but we're just solving an equation. But we'll call them x-intercepts or zeros. And they're when y equals 0. That's why we call them zeros. It's when the height equals 0. So if this is something going in the air, it's just when you have 0. If a company, this is more of a company breaking even. So starting at negative, breaking even, hitting a max profit, and then breaking even again if they're being inefficient. The vertex, which is the maximum point, the maximum value. So it's the maximum value here, but it could certainly be the minimum value. That's just the y value of the vertex. We know what this line's called. It's it really helps us draw the graph. It's called your axis of symmetry. It allows you to do things like, well, if you got a 0 here, then you obviously have a 0 here. And also, like, if we know where the zeros are and we know where the axis is, it's a way to find the vertex. Okay, and so that's basically all the main parts of a parabola. The quadratic functions in 3 forms. First form we got is, well, I guess we got them all here. The vertex form is A. We usually use these letters here: A, H, and K, A, B, C, and S and T. And these could be different things, but so vertex form certainly just tells you the vertex. So realizing that, like, when x equals h, because then we know that if we plug in h and here, this actually goes to 0, and this whole thing f of x actually equals k. And so we got our vertex, our highest or lowest point, the vertex at h comma k. Notice how it's like not negative h, it is h comma k, because it's the number that's easiest to sub in. That's what I always say. The number that's easiest to sub in for x is h, because that makes this whole thing 0, and we're just left with k. Also, like, we know that this is the maximum point because, like, basically we know about transformations. And we know the base parabola, which is just like right at 0, 0, is shifted to h comma k. It's shifted to the right or left and up or down. The next one, standard form, tells you the y-intercept, the most easiest, because the easiest number to sub in is x equals 0. If we sub in x equals 0, we get f of x equals c, or y equals c. And so your y-intercept, the point on the graph, is 0 comma c. And the last one is factor form. It easily tells you the zeros. The easiest numbers to sub in here are s and t, and those will actually give you 0. So when the function is 0, x equals s or x equals t. Since those brackets will make the brackets 0. A little spelling mistake there. And so that's basically what we just did in the last unit when we found our restrictions. This is just finding out the zeros of the parabola. Okay, so those are the 3 forms. The big idea is, like, different representations of the quadratic. So depending on which form it's in, tell us different key features more easily. So, like, this one easily tells us the vertex, and easily tells us the y-intercept. This one easily tells us the zeros. Now we're going to work at, and we did in grade 10, getting from one form to the next. And so, like, the next lesson, we're actually going to explore getting from standard form to vertex form. We've already done some standard form to factored form, so that's important. The other factored form, actually, it's useful to say, it could look like this, because it doesn't always have to be a common factor coming out. And so you might factor it looking like this. And so, like, it's really important to say that, like, your zeros in that case are negative b over a. Like, that would be like if you solved this for 0 or this for 0. So negative b over a or negative d over c. And so that's important to say because, like, factor form doesn't always look like this. It could also look like this as well. So these are just some practice questions to get you guys back into, like, just looking at quadratics, looking at the key features of quadratics. Number 1 does do, like, first-second differences. Like, you could research how to do those relatively easily if you're having trouble, but it's really just subtracting the y values. Okay.